Hi, we are Sweet Potato, and we are Ben, Celine, and Dave, and this is our NLP final project, final report.
The first one, I want to talk about our asking script. So we start off by over-generating questions from the sentences and then ranking them to pick the best ones. So our first step is we parse the sentences via the Stanford parser. And we do some sentence processing. For example, we reject sentences with commas or semicolons. We also reject sentences that are not of the form of S goes to NP-VP because generating questions from questions is really, really difficult. We also reject sentences as pronouns unless we explicitly replace them because the pronouns could refer to something else that are not in the sentence, and so the sentence will be out of context and thus unreasonable. And then for each prepositional phrase, we either keep it or remove it. And at that point, this allows us to generate shorter questions. And the first type of questions we generate is medium questions. We do this by taking the NP and the NP-VP and replacing with the Dutch WH word. And which WH word we choose is based on the head of the noun phrase. So for example, in Noah is happy, the head is going to be Noah, which is a person, so we replace it with who. And another kind of question we generate is yes-no questions. And this is done by adding, can we say that, in front of an existing sentence. And the reason why we do this is because for each personal pronoun or a human name, we swap it out with another random name that is in the article. So for example, if we have a passage that says, Noah likes dogs, David likes cats, we can generate a question that says, can we say that Noah likes cats? So from the passage, there's actually no way to answer this question, but instead of we're asking, can we say this, we can actually answer the question by saying, no, we do not have enough information to answer this question.
The next thing we do is to classify the questions in order to filter out the questions that are bad. That is, they are disfluent or ambiguous. For instance, in an article about Slumdog Millionaire, a good question would be something like, can we say that the movie ends with a dance scene? And a bad question would be something like, what ends? Because while that is technically grammatically correct, it is extremely ambiguous. It's hard to objectively assign a rank or a quality to questions when we are creating an example set, but we know a bad question when we see one, and that's why we chose to do binary classification. So for our classifier, the features we used were inspired by those used by Hillman and Smith in their 2009 paper. We used the number of tokens in the question that has been generated. We used the number of prepositional phrases, verb phrases, and noun phrases that are remaining in the question after it's been generated. So this allows us to identify questions like what ends and can we say that the movie ends, which are really short and don't contain enough information to be answered accurately. We also keep as a feature the question type as a series of binary variables indicating which WH word is used or whether it's a yes and no question. And we also likewise have a binary vector that indicates the tense of the question. We then prepared a large training set and we labeled any question that was even ambiguously bad because we would rather filter out good questions than allow bad questions to make it through the filter.
So now we're going to talk about our answering script. So we started off by actually pre-processing the article by doing some pronoun resolution. So there's two cases. If the article is about a person, this is determined by Stanford's name entity recognition, then we replace all personal pronouns with that person's name. And we keep it because it can basically refer to anything, and just randomly messing around with it is really bad. And on the other case, if this article is about a non-human, then we replace it with a title. For example, if it's about a constellation. And then we also remember the most recent person mentioned, and then replace the he, she, or these personal pronouns with that person's name.
So in order to run passage retrieval on the pronoun resolve text, we use NLTK sentence tokenizer to split the Wikipedia article, and we remove particular sentences which are just links or headings of sections which will not contain information. For the remaining passages, we use TF-IDF to rank the relevance of each passage by the number of terms that it has overlapping with the question. The answer sentence is usually the top ranked passage for the questions and articles that we observed. However, in some cases, using TF-IDF this way fails when a passage has more word overlap with the question but is not about the correct subject. For example, if there's a sentence in the article that says this movie won 8 BAFTA awards, and there's a question that goes, did this movie win 8 Academy Awards? Maybe the movie only won 7 Academy Awards, but the question structure and the passage that is incorrect have more in common. And so to solve this, we weight certain parts of speech more than others to ensure that we retrieve a passage that is about the correct subject. And then we simply return the top scoring passage as the answer. So that's our NLP program. Thank you for listening.